Okay, so good morning again. So this time we will discuss module 22, which is pile group efficiency. Okay, so last meeting for the rest of the finals, we discuss yung uh, capacity of driven piles or yung mga deep foundations, di ba? Which is yung driven piles. And we determine how to find the capacity of driven piles. Okay, so we have yung piles in sand and the piles in clay, and also we determine how to solve the capacity based on yung pile testing. Okay, yung static and dynamic pile load testing. Okay, so what will happen if the piles is in group? Okay, so the pile group, it may often be required to use more than one pile below a column. So depending on the column load and the load capacity of a single pile. So as you can see in actual piles, okay. So just like this one, in this figure. This figure is an example of yung um, deep foundations, okay, which is the piles of the Burj Khalifa. So this is the foundation of the Burj Khalifa. So they are acting in groups. Okay, so that is the usual na makikita nyo sa site. Okay, usually driven pile should be provided in groups. In a single pile should not be used. Okay. And also, depends din siya sa column load and the load capacity. Okay? So syempre kapag mataas yung demand versus the capacity. So as a designer, okay? Ang pwede mong gawin is to provide more piles, okay? To provide additional piles or to increase the size of your piles. Okay? So that is your options, okay? That is your options. Okay, however, mas madali yung capacity if you will add additional piles, okay, na the same size, okay, compared to increasing the size or increasing the diameter of your piles. Okay, bakit? Kasi the geotechnical engineers will be the one to provide the diameter of the piles. Okay? So, kung naaalala niyo yung pinaggagawa natin, 'di ba? We determine the capacity with calculations, 'di ba? Yung calculations yung based on sand, piles in sand versus the piles in clays. Okay? Then we have also the pile drive testing where the pile load testing, okay, has meron siyang requirement for the diameter and the length. Okay? So ang mangyayari kung ang sasabihin mo as your recommendation is to increase the diameter, what will happen is uulitin nila yung analysis nila. So kapag nag-increase ba sila ng diameter, ano na yung capacity nun? So mag-aano na naman, magkakandak na naman ng testing. Okay? Next na naman, nag-recommend ka ulit ng increase natin yung diameter. So kakandak ulit sila ng testing. So hindi na kayo matatapos. Okay? So the solution is, okay, ito talaga yung nangyayari. Okay? Same lahat nung size ng piles. Let's say for example 450 millimeters lahat. Same na yan lahat. Okay? The only option para maging adequate yung design mo is to provide additional piles. Okay? So you will make a group of piles na sila yung mag-a-act dun sa forces na yun. Okay? So ganun yung nangyayari. So this is because the pile may move laterally during the driving operation, resulting in the eccentricity of the load, causing additional bending stresses in the pile, decreasing both the structural capacity and the soil resistance capacity. So group action of piles is evaluated by considering the piles to fail as a unit around the perimeter of the group. So both end bearing and friction piles are considered in evaluating the group capacity. Okay, so in most cases, piles are used in groups. So as shown, to transmit the structural load to the soil. So ito yung mga example ng piles in a group. So a pile cap is constructed over the group of piles. So ito yung pile cap natin, class. Okay, this is your pile cap. Yan. And the cap can be in contact with the ground as in most cases or well above the ground as in the case of an offshore platforms. Okay? So basically, para lang siyang, kung i-imagine natin, para lang siyang isolated footing na merong piles. Okay? Parang ganun. An isolated footing na merong piles. Okay? So yan yung mga mga piles and yung pile cap. Okay? So in this section, okay, we have your pile cap, and let's say you have your piles. Okay, this one is your piles. We have a spacing D and a length of L. Okay, so when the load is applied, okay, so meron siyang load dun sa taas. Okay, then the reasonable assumption is that the stress transmitted by the piles to the soil will overlap, reducing the load bearing capacity of the piles. Okay, so meron tayong tinatawag dito ito yung effective stresses niya kapag nag-act yung load dun sa piles. Okay? So meron siyang parang ganito, parang semi circular na effective stress. And ang mangyayari kapag masyadong maliit, okay, yung spacing, okay, masyadong maliit yung spacing, this is spacing. Okay, masyado siyang masinsin, ang nangyayari, mag-overlap yung load-bearing capacity of the piles. So, anong mangyayari kapag nag-overlap yung load-bearing capacity of the piles? Kapag nag-overlap, okay, yung load-bearing capacity of the piles, it will reduce its strength. Okay? So, because, para bagang parang when you are waiting in the line, waiting online, di ba? Pag nag-wait ka sa line, kapag masyado kayong maraming tao, hindi kayo makakausad dun sa pila, sa linya nyo. Okay, pero kapag smooth lang yung flow nyo, smooth lang yung flow, mas madali kayong matatapos lahat. Okay, so in practice, the minimum center to center pile spacing is 2.5D, and in ordinary situation is actually about 3 to 3.5D. Okay, so in general, nagkakaroon ng reduce sa load bearing capacity of the piles kapag hindi maganda yung spacing ng piles, hindi maganda yung arrangement ng piles. Okay? Again, in general, there is a reduction of the load bearing capacity of the piles if your center to center spacing is not sufficient. Okay, so the efficiency of the load bearing capacity of a group pile may be defined as this equation. Okay, so we have this equation mu, okay, is equals to the ratio of the QDES in group and the QDES individual. Okay, your QDES in group is the designing strength, okay, designing strength capacity acting when the piles are acting as a group. And this one is the designing capacity of the piles when the piles is acting as individually. Okay, again, yung nasa numerator is the designing capacity. Okay, take note of the word designing capacity when the piles is acting as a group, and the designing capacity, okay, when the piles is acting as individual. Okay, so the pile efficiency in sand layer. So many structural engineers use a simplified analysis to obtain the group efficiency for friction piles. Okay, so particularly in sand, whereas the total capacity is highly dependent on the frictional resistance. So you can check this out. Okay, maybe open tayo ng capacity of driven pile foundations. Okay, let us check lang. Double check. Okay, let us double check. Okay. So let's have capacity of piles in the sand. Okay, capacity of piles in the sand layer. Okay. Okay, wala. Okay, wala dito. Okay, anyway, so for the capacity of the piles in the sand layer, okay, the total capacity is equals to the Q friction plus Q tip, or the frictional resistance plus the end bearing capacity, or yung aka bearing. Okay. But this time, yung Q tip mo is very small compared to your Q friction. Okay, therefore, we can say that this Q tip is negligible, and therefore the only factor, okay, that is highly affecting the total capacity is the frictional resistance. Okay, this one. So this type of analysis can be explained with the aid of the figure below. So depending on their spacing within the groups, the pile may act in two layers. Okay, the piles may act as a block, and the piles may act as an individual piles. Okay, so let's say for example this one. Okay, so in this figure, we have a plan view of a piles in a pile cup. Okay, then we have a effective area, okay, that the piles will act as a group. Okay, yung effective area na yon is the outside perimeter of the yung exterior piles. Okay, yung perimeter, okay, the perimeter of your exterior piles, okay, nasa labas na piles mo. Okay, so exactly dun siya mismo, dun sa pinaka end nung exterior piles, which is this one, and this one. Okay, this one. Okay, ito. So for example, ito siya yung tunay, yung may with pile cap. So kapag with pile cap siya, there is an edge spacing. Okay, meron siyang edge spacing. Okay, ito yung pile cap. But the only effective area is yung dito sa may outside of the exactly outside of the piles. Yan. That is the only effective for piles in acting as a group. Okay. So we denote as the length is L sub G, and the width is B sub G. And the spacing, center to center spacing of the piles is S. Okay. So therefore, yung block dimensions is basically LG times BG times the length of pile. Okay, that is the total block. Parang ganyan yung total block. Okay, so para siyang para siyang prism lang na isang malaking bloke. Okay, so length LG times BG times the length of pile. Then yung other ways that yung piles may act is yung acting as an individual piles. Okay? So lahat nung na-solve natin in module 19, yung capacity of the driven piles, that is acting as an individual piles. Okay? So ibig sabihin lahat ng na-solve natin na capacity doon is individual piles. Okay, is for individual piles. Okay. So let us find the total frictional resistance or frictional capacity for a piles in a group, acting as a group. Okay. So before we start, let us provide yung L sub G in terms of S okay, and the number of piles, and B sub G in terms of S and the number of piles. Okay, so number of piles basically is M by N. So parang how many piles, yung M natin is the number of rows in a piles and N is the number of columns. So in this example, we have 1, 2, 3. You have 3 rows. Okay, yung 3 rows is yung bilang niya, okay, number of x-axis. Yan. You have 3 rows. And you have 1, 2, 3. You have 3 number of columns in piles. Okay. Again, you have 3 piles in a row. And you have 3 piles in a column. Okay. So that is the number of piles, okay, which is M by N. So take note that your L sub G should be greater than B sub G. Okay, so let us find the relationship of L sub G in terms of N, S, and D, and diameter of the piles. Okay, so first, determine how many number, okay, to determine the total length LG, first is to determine the total number of spacing. Okay? So kung ito example natin na to, we have 2 spacing. Okay? So anong mangyayari naman kapag meron kang dalawang rows? Kapag may dalawa kang rows, ang mangyayari meron kang only 1 spacing. Kapag meron kang 4 na rows, 4 na columns. If you have 4 columns, what will happen is you have 3 spacing. So, ano yung nakikita nating pattern? The pattern is always the number of spacing is always is always 1, okay, less than the total number of columns. Okay, so kung ito sabi dito, we have 3 number of columns, okay, pero yung spacing natin is 2 lang. Dito meron tayong 2 columns pero yung spacing natin is 1 lang, and dito meron tayong 4 columns but yung number of spacing natin is 3. So therefore we can say that that is n minus 1 times s. So kung may n minus 1 times s ka na, ang nakuha na natin is the total length of piles. Okay, yung outside and outside length of piles na center to center na yon. Okay, so nandito na yon, nandito na yung distance natin na yan. Dito and nandito. Okay. So, ang kulang na lang is para maging outside, dagdag kayo ng half the diameter of the piles kabila and half diameter of the piles sa kabila. So, 2 times D over 2. Okay. The same case for B sub G, whereas this time M naman siya, which is the number of rows in piles, which is M minus 1 times S plus 2 times the half diameter para maging B sub G na siya. Okay, so therefore your LG is n minus 1 times S plus D, and your B sub G is M minus 1 times S plus D. Okay, so if the piles act as a block, the frictional capacity, if you recall, that is F sub AV, okay, multiplied by the perimeter of the piles. Okay, so if it is acting as a group, that is perimeter of the block, and multiply it by the length L para maging total surface area yung nag-act, and that is approximately the Qdes group. Okay, whereas your P sub G is the perimeter of the block, okay, and FAB is the average unit frictional resistance. Okay, so for the perimeter of the block, so basically that is the perimeter LG plus VG times 2. So perimeter siya ng rectangle. Okay, so LG plus VG times 2 or 2LG plus 2VG. So if we substitute yung LG and yung VG, you will have this 2S m plus n minus 2 plus 4d. Okay, bakit? Okay, so add mo lang to, yung n minus 1 at m minus 1. So therefore, you have m plus n minus 2. Then you have s plus s. Therefore, copy yung s since meron siya. So s lang siya. Then multiply it by 2. So you have 2s. Then you have d plus d. Okay, so d plus d is basically 2d. So times mo siya sa 2 because of the perimeter. Therefore, you have 4d. So therefore, you have 2s m plus n minus 2 plus 4d. So you can check this out. Verify this perimeter of the block. Okay, and FAB is the average unit frictional resistance acting on the the surface area of your block. Okay, again, the block is LG times BG times the total length of piles. So basically, para siyang isang malaking piles na rectangular na lang. Okay, isang malaking piles na rectangular para maging acting as an individual. Okay, so similarly for each pile acting as individual, your Q dash individual is equals to P times L times FAB. Okay, and your P is the perimeter of the cross section of each pile. Okay, and M by N is the product of number of piles in a rows and in columns, total number of piles. Okay, so for Q dash individual, okay, so ang gagawin mo lang, you just sum up the total PLFAB or yung total resistance ng each pile. So for example, meron kayong 3 piles. Okay. Mayroon kayong 3 piles. So if the assumption is it will act as individual piles, so therefore kapag ang capacity nito is 200, so same dimension sila, same diameter, same dimension. Ito rin is 200. This one is also 200 kilonewton. Okay? So basically, ang gagawin mo lang, kunin mo lang yung isang capacity ng piles, multiplied mo by the total number of piles, you will have your capacity, okay, of a group pile acting as individual piles. Okay? So para siyang 100% efficient. Okay, yun na lang. Para siyang 100% efficient that the capacity of individual piles is governing. Yan. So therefore, since the formula n or nu, okay, is the efficiency is the ratio of Q dash in group and the Q dash individual. Okay, so for the Q dash in group, okay, so you have your FAB, you have your perimeter of the block, okay, you have your total length L. And for the Q dash individual, you have the total number of piles, which is M by N. Okay, the total number of piles is M by N. You have your P times L times FAB. Okay, your piles in the capacity of piles individual. Okay, so therefore we can cancel out FAB and the L. Okay, cancel out FAB and L. What you have left is 2S M plus N minus 2 plus 4D all over M, N, and P. Okay, so therefore, this is the final equation for piles, okay, acting as a group. So ano yung efficiency niya? Ano yung efficiency ng piles natin? Okay, ano yung efficiency ng piles natin acting as a group? So parang ang nangyayari, yung 100% efficient is piles acting as individually, pile acting individually, that is the 100% efficient. Okay, and the efficiency factor nu is given by this equation. Okay, given by this equation. So whereas your S is the center to center spacing, your M is the number of rows, N is the number of columns, D is the diameter of the piles, and P is the perimeter of the piles, okay, at the ends, okay, pinaka sa ilalim. Okay, so from the equation above, if the center to center spacing S is large enough, Okay, therefore, your mu is greater than 1. Okay, so let's say for example, your S is very large. The center to center spacing is very large. That the efficiency mu is greater than 1. So in that case, the pile will behave as individual piles, and in practice, we cannot use mu that is greater than 1. We cannot use 200% efficient. We can't use more than 100% efficient. So in practice, we are using mu that is greater than, if mu is greater than or equal to 1 or greater than 100%, we just simply use the 100% or yung Q dash individual. Else, if your mu is less than 1, you will use mu efficiency multiplied by the Q dash individual. Okay, again, we are not using mu that is greater than 1. So parang may ganito siya. Your efficiency should be always less than or equal to 1. Okay? So you cannot use an efficiency that is all greater than 1 for practice. Okay. So we have the typical pile arrangement. Okay, so if you're working now in the industry or you have your own company, you can check this typical piles arrangement or typical pile arrangement. So kapag meron kang piles na meron pa ditong tatlo so hindi na ilagay. So pag 3 piles, ganito yung typical arrangement. Okay? Yan yung arrangement. And kapag 2 piles lang, ganito yung arrangement. Okay, so hindi siya nasama. 3 piles and 2 piles. Yan. Meron ba dito? Ayun, sorry. Meron pala dito. Okay, anyway. So for the typical arrangement of piles in a pile cup, so we have your 2 piles, 3 piles, you have your 4 piles, okay? 5 piles, okay? 6 hanggang 20. Okay, so mapapansin nyo, ano siya, parang symmetric talaga yung arrangement of piles. Okay? And the rectangular one on center is yung columns. Okay? Yung rectangular on center is columns. Okay. So also pwedeng mangyari yan sa site. Ganito yung mga problem sa site Okay, the problem is hindi yan eksaktong nailalagay sa site. Hindi yan perfectly nailalagay. Minsan yan nangyayari. In-experience ko dati. Yung piles, okay? So, let's say 4 piles lang yan 4 piles. So, ang nangyari, nailagay dito yung piles. Dito na i-driven yung piles. So, nagkamali yung surveyor nila. So, dito yung iba, dito yung iba, dito yung iba. So what will happen? Okay? So nire-design yung pile cap. Okay? Kasi yung piles hindi na ma-design yan ulit Since given na talaga yung diameter of the piles and the capacity of the piles. Kasi based on geotechnical report, given na siya. So nangyari, kailangan mong mag-provide ng pile cap, yung paglalagyan ng piles. So kasi ganito, nagkaroon siya ng additional eccentricity. Okay, later on, malalaman niyo paano ba nagso-solve nung capacity ng mga piles. Nung reaction ng piles. Okay, so I think i-discuss siya in module 23 for the capacity of for the reaction of piles. Okay, so ganon. So meron siyang additional eccentricity. So therefore, yung pile cap cannot carry yung ganitong scenario. So ang nangyari, i-increase natin yung pile cap. Okay, increase yung pile cap. So nangyari, redesign yung buong yung maraming mga ganyang cases maraming hindi eksakto na ilagay yung piles. So yan yung mga cases, typical cases. So ang nangyayari, kailangan mong i-redesign yung mga pile cap mo. Okay? So hindi yan perfectly na ilalagay talaga. So ang ginagawa niyan, coordination sa site and coordination dun sa designer. Sinesend yung coordinates sa AutoCAD. Okay? So I think you already know how to use AutoCAD. Okay? So meron dong coordinates na sinesend. Nandun nakalagay yung file cap. So mapapansin mo para siyang naka letters lang. Naka numbers lang. Then ang gagawin mo, magpuput ka lang ng circle doon sa bawat coordinates na 'yon. Yan yung mga ginagawa. Okay? So very crucial talaga yung paglalagay nung surveying, yung trabaho ng surveying kasi kailangan eksakto yung positions ng mga files. Okay. So also we have yung typical file arrangement sa mga with common spacing. Okay? So meron tayong for 2 files, 3 files, hanggang 8 files. So ito yung mga typical spacing na nakikita natin sa mga files. So typically 3D yung mga spacing, 3 times the diameter, and yung edge spacing is 1.5T. Yan. Okay. Okay. So you can use this one, yung additional for additional for the this one. So for the minimum design parameters, the typical pile spacing is 0.9 meters for concrete piles, 0.76 meters for timber and steel H5 or H piles. Then yung pile embedment to footing, okay, yung embedment ng piles dun sa footing, you need to provide 0.15 meters. Okay? Siya yung embedment ng piles. So hindi kasi eksakto yan na kailangan yan may anchorage. Okay? So for example, ito yung piles. Okay? Yung pile cap, and merong piles sa ilalim. So meron siyang embedment ng konti. Okay, a minimum of 150 meters. Yan. So ito, okay, this one is a minimum of 150 millimeters. Yan. So meron siyang embedment. And also, okay, nasa na siya? And also, yung clear bar covering. Okay. Yung pile edge distance. So for the typical pile edge distance is 450 millimeters or 0.45 meters. And the clear bar covering, 3 inches above the top portion of the pile embedded to footing. So, pwede nyo questionin yung ginagawa sa site. Okay. Yung start po ng clear cover sa ilalim is dito mag-start sa top ng embedment ng piles. So, dito mag-start yung 75 mm. Dito mag-start yung 75 mm. Okay. Sige. So that is yung minimum at the typical arrangement of piles and yung typical spacing and edge distances. Okay. So let's have an example problem. Okay. So example problem. So this is a past board exam in November 2005. Okay. So you can see mga ganitong problems. Okay. You will see mga ganitong problems sa board exam. Okay. And pag nangyari yun, syempre alam niyo na kung paano siya i-solve. Okay. So a pile group consists of 12 piles with a diameter of 0.3 meters and a pile length of 12 meters is shown in the figure. Okay. So the piles are spaced in a 3 pile by 4 pile rectangular configuration. So ito siya. Meron siyang 3 rows and 4 piles in columns. Okay, 3 rows and 4 columns. Okay, and the pile spacing is 0.6 meters center to center. Okay, so the piles are driven into clay that has given characteristics. Okay, so hindi kasi actually yung pile group efficiency, kahit nasabi nila na para lang ito sa sand, ginagamit na rin to for clay layer since this is an approximate efficiency, this one. So minsan ginagamit na to sa clay layer. But if you are a geotechnical engineer and meron silang ibang formulas na ginagamit for the for the efficiency new for the okay yung for group. So medyo higher na, medyo advanced na yung analysis nila. So I don't know. Okay, but the pretty basic is this one. Okay. So again, determine the allowable load on the pile group considering that the pile will act as individually and using a bearing capacity factor NC, that is 9, a factor of safety, that is 3. Use alpha method. Note, if not all given, always use alpha method. Okay. So in our problems, kapag may nakita kayo na hindi naka-indicate kung magagamit ng alpha method or beta or gamma, okay, always use alpha method. Okay, you can call me out kapag minalian ko kayo and hindi ko nalagay yung method na gagamitin. Okay, but pinilit ko na ibang method, let's say beta or gamma. So you can call me out na sir, alpha method lang dapat kapag ang default natin. Okay. So next is determine the allowable load on the piles considering group action. So use assumption for the sun. Okay, and number 3, what would be the minimum pile spacing to achieve 100% efficiency? Okay, so let us try. So una, hanapin daw natin yung sorry. So hanapin daw natin yung allowable load of the piles considering that the piles act individually. Okay. So if you recall the formula for the piles acting on clay, so you have your CNCA tip and you have your clap. Okay? Which is yung clap, yung C, cohesion, alpha, length, and perimeter of the pile. Okay? So ito siya. Okay, para ma-review na lang din kayo. Okay. So piles in a clay layer using alpha method, you will use clap CL alpha P. And for Q-tip, you will use CNCA tip. Okay. So for the ultimate, so for the capacity, we have the sum of Q sub tip and Q sub F or yung friction. Okay. So for the Q sub tip, we have your CNCA tip. So what is your cohesion value at the end of your clay layer? So this is your cohesion value at the end of clay layer, which is 95 kPa. Take note, this is clay ha. This is clay. So hindi mo na kailangan gamitin ito. So clay layer siya. Okay? So therefore, yung pinaka last layer niya, so my end is 95 kPa. So you will use cohesion value of 95. What is the given bearing factor? The given bearing factor is 9. Then A tip. Okay, what is the perimeter area of the tip? So that is pi over 4 times 0.3 squared. Therefore, the end bearing capacity is 60.44 kilonewtons. Okay. Next, using the clap or yung alpha method, C alpha P times L. Okay. Okay. So you have your C, which is 58. Okay. Sorry. I don't provide yung alpha. Okay. So if not given, then the value of your alpha, okay, yung frictional factor, you can use 1.0 kapag hindi rin given. Okay, so in this case, the alpha is equals to 1 frictional factor. Okay, so again, if not stated, yung alpha factor is 1.0. Okay, so alpha method, so clap. So your C, which is in the first layer, Okay, in the first 4 meters, your cohesion value is 58. Okay, then the surface area, so that is pi d times length L times alpha, which is 1.0. So pi d times L 4. Next, the second layer, we have different cohesion. So we have 76 kPa times pi times 0.3, which is the perimeter, times L, which is the length L, 5 meters. And for the third layer, okay, we have 95 kPa cohesion, and the surface area is pi times 0.3 times 3. Okay, so therefore your frictional resistance is 845.4 kilonewtons. Okay, so if you find the total capacity, that is 60.44 plus 845.44, that is 905.84 kilonewtons. Okay, the question is, ano daw yung allowable load using a factor of safety of 3? So yung 905.84 kilonewton doesn't have a factor of safety of 3. So therefore, you will divide this to 3.0, and therefore your uh, uh, allowable capacity is 301.95 kilonewtons. Okay? Okay? So you have your 301.95 kilonewtons. Okay, so therefore, the total allowable capacity for the piles acting as individual, okay, uh, so you will just simply multiply the number of piles to the capacity of each pile. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 piles, okay, or 3 by 4. So 3 times 4, okay. And the capacity, the allowable capacity of each pile is 301.95. Therefore, the total allowable capacity of these piles in a group acting as individual or acting individually, okay, you have 3,623.4 kilonewtons. Okay, so this will be your final answer for allowable load considering that the piles act individually. Okay, so next is allowable load considering group action, so group efficiency. So ito kasi nakadepende to dun sa spacing, sa diameter, and the number of piles. Okay. So for the spacing of piles, for the efficiency of piles, new, okay, you have the formula 2s m plus n minus 2 plus 4d all over the m times n times the perimeter of the pile. Okay. So, ano ba yung M at N natin? So, you have 1, 2, okay. So, this is baliktad. It should be number of, so this will be your N and this will be your M. So, it doesn't matter if magbaliktad naman yung M at N. So, based on the formula, ito lang naman siya. Okay? So it doesn't matter kung mag-interchange, but doon tayo sa binigay nating definition. Okay. So your M is the number of rows, 1, 2, 3. Okay. So, and sorry, the N is the number of column, which is 1, 2, 3, 4. Okay. Okay, then for the spacing, we have 0.6 meters spacing of piles. And for the diameter D, that is 0.3 meters. Okay, so therefore the efficiency is 2 times 4 plus 3 minus 2 times 0.6 plus 4 times 0.3 divided by 4 by 3 times the perimeter. What is the perimeter of the pile? The perimeter of the pile is pi times d, since circle yan. So pi times t, which is 0.3. Okay? And therefore, the efficiency is 64% or 0.64. And if you can check yung formula natin, this should be always greater than 1.0. So therefore, that is okay. And also yung mu natin, yung mu natin is equals to Q des in group over Q des acting individual. Okay, so therefore your Q des and group is equals to nu then multiplied by the Q des individual. So meron na tayong Q des individual, di ba? Yung solve natin sa problem 1. Okay, so the Q des individual, so 3623.4, multiply mo siya sa efficiency 64%. Therefore, you have your 2,318.95 kilonewtons allowable load considering group actions. And last question is, what is the minimum pile spacing to achieve 100% efficiency? Okay, so to achieve 100% efficiency is basically use this equation and find the spacing S. So efficiency is equals to 2m plus n minus 2 times S plus 4d over mn pi d. Okay, and substitute all the values of m, which is yung 3, n is for the diameter is 0.3 and the perimeter is pi times d. And solve for S, you will have your 1.01 meters. Okay? So dito nyo lang makukuha yung pile spacing if ay nahanap yung pile efficiency. Okay, any more questions for pile group efficiency? Anyone? May question ba kayo?
No po, sir.
Okay. So that's all for our pile group efficiency. So basically hanapin nyo lang yung efficiency based on the equation. Okay, yung equation natin. Okay. And also nangyayari lang yung pile group efficiency, okay, sorry, yung reduction of the soil bearing capacity of the piles or yung bearing capacity of the piles if, okay, take note of this one so sana hindi nyo ito makalimutan kapag nagtatrabaho na kayo sa industry. So magkakaroon ng pile group efficiency, okay, acting as a group kapag hindi enough yung spacing ng piles in the pile cap. Okay, magkakaroon again ng pile group efficiency, okay, na mababawasan yung bearing capacity ng piles kapag hindi enough yung spacing. Okay, so that's it for our discussion for the pile group efficiency, and okay, I'll stop sharing.